Hi folks, it's Calc 2 Take Home 9. We're asked to find the length of one arch of this cycloid. Now from class we're going to remember that one arch of this cycloid happens as t runs from 0 to 2 pi. So to find the arc length of this, I'm going to integrate over the curve C the arc length differential. And if you remember back to class, how do we get the arc length differential? Well, we take dx dt, the derivative of x with respect to t, square it, dy dt, square it, add them up, take a square root, dt. So, what's dx dt? Derivative of t is 1, minus derivative of sine is cosine. What's dy dt? Derivative of 1 is 0, minus negative sine, so it'd be positive sine t. So if I take 1 minus cosine t squared plus sine squared t, let's see what I get. 1 minus 2 cosine t plus cosine squared t plus sine squared t. We have Pythagorean magic happen here, that's equal to 1. I'm going to get 2 minus 2 cosine t. So that gives us our arc length differential. ds is equal to the square root of 2 minus 2 cosine t dt, which we can factor a 2 out and get a square root 2 times the square root of 1 minus cosine t dt. So that's the arc length differential. Okay, so for the integral then, the arc length s is the integral over the curve C ds. In terms of t then, I'm going to be integrating from 0 to 2 pi, square root 2, square root 1 minus cosine t dt. Now the question is, how do I negotiate this integral? Well, we can go back and look at the double angle formula for cosine. So cosine of 2 theta, one of the variations is it's 1 minus 2 sine squared theta, which means that 2 sine squared theta is 1 minus cosine 2 theta. So I can replace 1 minus cosine t with 2 sine squared t over 2. So I've got a radical 2 out front, integral from 0 to 2 pi, square root of 2 sine squared t over 2 dt. I can take the 2 out as a square root and get a 2 then out front, integral 0 to 2 pi, and then I'd have the square root of sine squared. That gives me an absolute value of sine of t over 2 dt. And now I look at my values for t. As t ranges from 0 to 2 pi, t over 2 ranges from 0 to pi. And in those, and from 0 to pi, the sign is a positive number, so I don't really need those absolute values after all. I just get this. So the integral sine t over 2 is going to be roughly negative cosine t over 2. I'm off by a factor of 2. So this antiderivative works out to be negative 4 cosine t over 2, evaluated from 0 to 2 pi. So I get negative 4 cosine of pi minus a negative 4, or plus 4 cosine 0. I get 4 plus 4, which is 8. And that'll do it then for take home 9.